Hi guys, I hope you are all doing well. Let's see today's question. So today's question I am taking this up from the topic of differential equations. And if I talk about the question which is given to us here from this topic, the question tells us that y equals y of x is the solution of a differential equation, and the differential equation given to us is 2x square plus x raised to 5 by 4 dy minus y x plus x raised to 1 by 4 dx. That is equal to 2x raised to 9 by 4 dx. And if I see x is greater than 0, that is also given to us that x is positive. And it also tells us that the solution passes through the point 1 comma 1 minus 4 by 3 log 2 to the base. So basically, if I put that x and y points in my solution, I'll get the constant c with this condition. And I have also been told that we have to find the value of y of 16. Means we have to find that at x equal to 16, what is the value of y. If I see the answer choices that are present here, it says for 31 by 3 minus 8 by 3 log 3 to the base. Second, it says 31 by 3 minus 8 by 3 log 3 to the base e. Third option, 31 by 3 plus 8 by 3 log 3 to the base e. And the last option given to us here is 4 times 31 by 3 plus 8 by 3 log 3 to the base e. So we have to find out which one of the answers is the correct answer choice for the question given to us. So let's first of all try to solve this differential equation. So 2 times x square plus x raised to 5 by 4 dy minus y into x plus x raised to 1 by 4 dx is equal to 2x raised to 9 by 4 dx. So when I have this differential equation given to us here, it says that if I try to convert my differential equation to in a general form, that is dy by dx plus dy equals to q. So what I need here is with dy, I don't need this fraction, the entire expression, and below dy I need dx. So what I'll do is divide throughout by dx, because everywhere I can see dx is present on the other two sides, so it will get cancelled. And I'm also dividing, I don't need anything with dy, so I divide by 2x raised to 2 plus x raised to 5. So I divide by 2x plus x raised to, and here also if I divide 2x square plus x raised to. So let's solve this. So what you get here is this gets cancelled and you get dy by dx. So you have the first part of the general form as dy by dx now plus py. So minus x plus x raised to 1 by 4 upon 2 into x square plus x raised to 5 by 4 into y is equal to, because dx and dx gets cancelled, is equal to 2 and 2 also gets cancelled, dx cancels, you are left with x raised to 9 over 4 divided by x square plus x raised to 5. So you have this entire equation now in the form of dy by dx plus py equals to q. But let's try to simplify the values of p and q if we can. So if I try to simplify this, what I can do here is from x square plus x raised to 5 over 4, 5 over 4 is smaller, right? So I will try to take out x raised to 5 over 4 common here. So if I try to do that, let's see what we are left with. So if I do that, get dy by dx minus. Here also I can see x raised to 1 over 4 and this is x. So nothing is there means you have here 1. So 1 is greater than 1 by 4. So if I take out 1 by 4 common, I'm left with x raised to 3 by 4 plus 1 y upon 2 x square plus x raised to 5 over 4. So 5 by 4 and this is 2. 2 is nothing but 8 by 4. So if I again take x raised to 5 by 4 common, I'm still left with x raised to 3 by 4 plus 1. This is equal to, sorry, so I should write equals to first. And here I have x raised to 9 over 4. And here also if I try to take out common again, x raised to 5 by 4, it's common. So you are still left with x raised to 3 over 4 plus 1. So what I can see here is I can actually cancel this entire thing. And when I cancel this entire thing and if I bring this x raised to 1 by 4 in the denominator, it becomes x raised to minus 1 by 4. So you get the expression as dy by dx minus y upon 2 x raised to 5 over 4 and x raised to minus 1 is equal to x raised to 9 over 4 and this 5 by 4 if I take it up, it becomes 9 minus 5 upon x raised to 3 by 4 plus 1. So if I solve this, I get this as dy by dx minus y over 2 x raised to 5 by 4 minus 1 by 4, that is 4 by 4. So 4 by 4 is 1. So x raised to 1 is equal to, this becomes x raised to 9 by 4 minus 5 by 4 again. So 4 by 4, that is x upon x raised to 3 by 4. So now if I try to compare this equation with my general form, I get dy by dx plus by equals q. Now if I compare this, I get from this two comparisons, p is equal to minus 1 over 2x and q is equal to x upon x raised to 3 by 4 plus 1. So you get this entire p and q now. Once you have p and q with you, you can just use the ideas. If integrating factor is given by e raised to integral p dx. That is e raised to integral p is nothing but minus 1 upon 2x dx. That is nothing but e raised to minus half. Integral of 1 upon x, that is log of x. That gives us e raised to log of x raised to minus. So that tells us e raised to log of f of x is f of x. So you get x raised to minus half. Now once you have x raised to minus half, that is your value of integrating factor. I get my solution here of the differential form as equal to y into integrating factor if is equal to integral of q into if dx plus c. So if I put my solution of differential equation in the form, I get y x raised to minus half is equal to integral q. Q is x over x raised to 3 by 4 plus 1 into integrating factor, that is x raised to minus half dx plus c. So what you get here is y over x raised to half, that is root x. It is equal to integral of x raised to half upon x raised to 3 by 4 plus 1 dx plus c. So now if I try to solve this integral, let's do that. So if I try to solve this integral, I'll have to substitute x as something. So if I see here in the fractional powers, I have in the denominator 4. So if I want to convert that and remove that, eliminate that 4, what I can do here is I can put a substitution here that x is, let's say, t raised to 4. So if x is t raised to 4, you get dx as 4 t cube dt. So you get dx as 4 t cube dt, and if you rewrite your integral first, let's try to first solve the integral now. So if I have, let's say, this is I, so I'll substitute this as integral I. And if I try to solve this integral I first, integral of, let's put that. So x raised to half, so x is t raised to 4, so t raised to 4 raised to half. That is basically t square actually. And then we have dx, which is 4t cube dt over. Denominator we have x raised to 3 by 4. So x we put as 3 raised to t raised to 4. So t raised to 4 raised to 3 by 4 plus 1. So that's your entire integral I. And if I solve this, I get t square 4t cube dt over t cube plus 1. So what you get here is t cube plus 1. And once you solve for that, if I try to solve for that, I get I as 4 I outside the integral. You have t square into t cube. And if I try to frame t cube in terms of my denominator, I can write that as t cube plus 1. So if I try to write that, I have to subtract 1 as well. So that I have t cube at the end and t cube plus 1 dt. Now if I split my integrals I get for integral t square into t cube plus 1 over t cube plus 1 dt minus integral t square over t cube plus 1. So if I try to solve this integral, let's see what I get. So I get this cancelled. You have only integral of t square dt here. And here you have integral of t square over t cube plus 1. So if I try to put, again to solve this integral, if I try to put, let's say this as any other alphabet, let's say t cube plus 1 is u, I directly get the derivative of that present. So 3t square dt is equal to du. So I get from here t square dt is equal to du by 3. So I get du by 3, and if I take that on the other side, I get I is equal to 4. Integral of t square dt is nothing but t cube by 3 minus, in terms of integral q, if I write it down now, you have integral of t square dt. I know it is du by 3. So du by 3, and this is u. So you get 1 by u. So from there I get 4 by 3 g cube minus integral of 1 by 3 here. If I try to solve that, integral of 1 by u is nothing but log of u plus c. So you get this entire thing 4 by 3 t cube minus log of u, we have put that as t cube plus 1. So log of mod of t cube plus 1. So you get this entire thing here after solving. Now if I further try to solve this, let's see what I get. So I have my value of the I integral here, and once I have that value, I put that here instead of my solution of differential equation. So my solution of differential equation changes to y over root x is equal to value of the integral, which is 4 by 3 t cube. So if I again resubstitute t also in terms of x, I know I had put x as t raised to 4. So t from here becomes x raised to 1. So when I put t as x raised to 1 over 4, x raised to 1 over 4 over 3, so I get x raised to 3 by 4 minus, here you get log of x raised to 1 over 4 over 3, so x raised to 3 by 4 plus 1 plus c. So this becomes your entire solution of the differential equation given. Now, once I have the entire solution of the differential equation given, it says that this entire solution passes through the point 1 comma 1 minus 4 by 3 log 2 to the base. Means at x equal to 1, we are substituting y as 1 minus 4 by 3 log 2 to the base. So if I put that in my solution of the differential equation, I get that as 1 minus 4 by 3 log 2 to the base e over 1 is equal to 4 by 3 x raised to 3 by 4. So x in this case is 1. So 1 raised to 3 by 4, which is 1 minus log of 1 plus 1, that is 2. So you get log of 2 and plus c. So if I see here, I get 1 minus 4 by 3 log 2 to the base e is equal to 4 by 3 minus 4 by 3 log 2 to the base e. plus c. So this I can cancel it because it goes on the other side, becomes plus. And from there I get c is 1 minus 4 by 3, which is nothing but 3 minus 4, so minus 1. So I get the constant's value, that is c is equal to minus 1 by 3. Now once I have the value of the constant c here, that is minus 1 by 3, I can just find the solution of the differential equation. So if I find the solution of this differential equation that I've got already, putting the value of c here, that is minus 1 by 3 in this differential equation, we know c is minus 1 by 3 now. So once I put that c's value here, and then we have been asked to find the value of y at x equal to 16. So if I put at x equal to 16 in my solution of the differential equation, my solution becomes y over root of 16, which is 4, is equal to 4 by 3 x raised to 3 by 4 means 16 raised to 3 by 4. So 16 raised to 3 by 4 means you're finding the cube of 16 and you're taking 1/4 root of 16. So 1/4 root of 16 is 2 and 2 cube is 8, minus log of 16 raised to 3 by 4 plus 1 minus 1 by 3. So you get this entire thing. Now if I solve for this, y over 4 is equal to 4 by 3. 16 raised to 3 by 4. So 4th root of 16 is 2. 2 cube is 8 minus log of 2 cube is 8. 8 plus 1 is 9. So you get log of 9 to the base e minus 1 by 3. Now you have this entire thing. If I multiply 4 throughout, first of all, let's try to solve this right hand side, then we'll multiply by 4 throughout. So y over 4 is equal to 4 by 3 into 8, that is 32 by 3 minus 1. So 31 by 3 minus 4 by 3 log 2 log 9 to the base. So if I multiply 4 throughout, I get this y turning out to become 124 by 3 minus, this becomes 16 by 3 log 9 to the base. So you get this entire thing here. If I try to solve this further, taking something common here, and if I try to convert it in my terms of the options given. So options are given in terms of log 3 actually. So we need to have log 3, and it is also 31 by 3 first. So I have to take 4 common. I understand that. So if I try to take out 4 common and if I convert my logarithm to 3 here, it becomes 4 common. So 31 by 3 minus 4 by 3 and log 9 to the base e, I can write that as log 3. So 2 comes in the front and gets multiplied with 4 by 3 becomes 8 by 3. So you get the answer as 31 by 3 minus 8 by 3 log 3 to the base. So if you see the answer choice that matches here with the question, the answer is option. So A becomes the correct answer for the question to us. I hope you have understood how to solve this type of questions which deals with the ideas of solving the differential equation. So we get the answer as A. So first we converted our entire differential equation in the form of dy by dx plus by equals to q. Once we did that, we solved for if getting integrating factor x raised to minus half. Then we used a solution of differential equation. We got this entire equation. We solved for this integral I, and further when we solved it, we got the answer for the solution of this. Then we solved for c and we got the value of c as minus 1 by 3, putting x equal to 1 and y equals to 1 minus 4 by 3 log 2 base. Once you got the answers for c also, you put at x equal to 16. We found the value of y and that turns out to match with option A. So A becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions which deals with the ideas of differential equations of the general form dy by dx plus by equals to q. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on 11th, 12th, as well as JEE mains. So stay tuned for more videos to roll out. Also, do like, share, and subscribe to my channel. Do share these videos with your friends who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.